example 4. This is, we want to sketch the curve expressed by the following parametric equation. And this is fairly simple. We're going to say that x equals sine of t and y equals sine squared of t. The solution itself is fairly easy. If x equals sine t, then y that equals sine squared of t is really x squared. So we're looking at y equals x squared. But what is the difference between y equals x squared as we know it using Cartesian coordinate system or Cartesian or just the function, and the parametric equation x equals sine t and y equals sine squared t? Well, one of the things that we're going to look at is if x equals sine t, what will be the domain of x? Well, the domain of x will be the range of the function sine t, right? So, here we need to pay attention. Notice that the domain of x equal range of sine t. And the range of sine t, if you remember, is -1 to 1, right? Because the sine function can go from -1 to 1. So x goes from -1 to 1. And therefore y will go from, since y is x squared, right, y will go from 0 to 1. So this is not your run-of-the-mill quadratic function y equals x squared. It's limited, it's bounded by -1 to 1 on the x side and 0 to 1 on the y side. So what really happened is the following. Okay? If x is bounded by -1 to 1, the parabola y equals x squared is now the following. Let's make x equals 1 and x equals -1 and y equals 1. So the parabola is going to look like this. It's this part of the parabola, and it has a points right there, and I'm not sure what's the end point, what's the beginning point. So let's see what happened. The beginning point or the initial point will be, okay, a comment about what we wrote previously. Okay, let me take this page. Since we are dealing with x equals sine t, and we know that one cycle of the sine t is 0 to 2 pi. Every time, if we'll go, let's say, from -infinity to infinity, it doesn't matter. The sine is a periodic function. So we can take one period, and we can say, for one period of x equals sine t, t will go from 0 to 2 pi. And we don't care after that because it's going to be simply repetition. So if you go 2 pi to 4 pi, 4 pi to 6 pi, or -2 pi to 0, -4 pi to -2 pi, it's all going to be the same. The point is t is a value between 0 and 2 pi. Okay, so keep that in mind. So t is a value, let me write it here, t goes from 0 to 2 pi. And let's see what happened. Initial point when t equals 0, what does it happen? What happened to x? X equals 0, right? So this should be the initial point right there. What happened with the final point? Well, the final point corresponds to t equals 2 pi. But what happened to x, sine of 2 pi? It's still 0. So you're going to say, wait a second. The origin is both the initial point and the final point. But if you think about it, we're going to see it one more time. Okay? We can talk about the midpoint, even though it's meaningless most of the time. T equals pi. And once again, x equals sine of pi, x equals 0. So we're going to visit this point 3 times. Okay? What about this point here at x equals 1, and what about this point here at x equals negative 1? Well, this corresponds to t equals pi over 2. Right? And this point corresponds to t equals what? Between 0 and 2 pi? Negative. But negative pi over 2 is not on the interval 0 to 2 pi. 3 pi over 2. Very good. So, if you think about the motion, we start at the origin, we go all the way up here at t equals pi over 2, and then we move back. At t equals pi, we are back where we started, and then we go this way between pi and 3 pi over 2. We get to 3 pi over 2, and then we go back, and we end up at pi. So you can see a pendulum motion here. If one cycle, we start right here, we go from here to here, and then we go back, we go from this point to this point. This would be from pi over 2 to pi to 3 pi over 2. So first quadrant, we go from the origin to pi over 2. Second quadrant, we go back to the origin. Third quadrant, we go to this point, and fourth quadrant, we go back into the origin. This is the motion of this particular function, parametric equation. That's why we said there is a difference between a curve. A curve is just a collection of xy points. A parametric curve is where you can trace the movement of xy along the curve. Okay? I believe there was a question.